series of function of one variable. Now you see that the Taylor series expansion for the two variables one by one. What shall I do? First, we consider the expansion, Taylor series expansion with respect to x. So y plus k will be remained as constant element. Okay. So fx plus h comma y plus k will be constant. Then it will be fx y plus k, then h del x of fx y plus k and plus h square del square by factorial 2 del x square f y plus k, and higher terms are there whose contribution is reducing. If we expand the term, the contribution will be less and less. So now what we'll do is, now we expand this f x y plus k. Here, first term. Expand the first term, then it will be f. Now expand in terms of y also. So it will be fxy plus k del y of fx plus k square by factorial 2 del square of fxy plus dot. This is the first term. Then h into del x fxy plus k del x of fxy plus dot dot. So expanding in terms of y now. Now the next term is h square by factorial 2 del square del x square. Now expand. So why I put dot dot? Because this contribution is not required. The contribution of the next term, that is h k del y of fxy in this case, because already double differentiation is there. So contribution is becoming less and less. So ultimate the result is, you can understand clearly that the result is fxy plus bracket h del f del x plus k del f del y. We have just clubbed the similar terms. We have clubbed the similar terms. We get h del f del x plus k del f del y plus other terms h square factorial 2 del square del x square plus hk del square y f del x del y plus k square by factorial 2 del square del y square. We shall use this one, right? The last one we shall use fxy plus bracket h del f del x plus k del f del y plus h square by factorial 2 del square f del x square plus hk del square f del x y del x del y plus k square by factorial 2 del square f del y square plus higher order terms. So just we shall forget about this, because contribution as we go to the higher orders, the contribution will be less and less. Symbolically, we can write fx plus h y plus k is equal to fxy plus f del x del y plus k del f del y plus f is taken common, so it can be taken out. It's very simple. If you just intake it, it will be del f del x. We can keep outside the sign. Okay, then 1 by factorial 2 h del f del x h del x plus k del y of whole square f, then 1 by factorial 3 h del x plus k del y cube f. This is coming from here. We can write these terms because we can, it is easy to memorize this also, because fxy then h del x del k del y f, then 1 by factorial 2 same thing h del x plus k del y whole square f plus 1 by factorial 3 h del x plus k del whole cube f. So this is easy to remember this form. Now some corollary, that is sometimes something is put, then what will be the result? Write a for x and b for y. Then let fx is equal to fxab denote the value of the partial derivative with respect to x, or x is equal to a and y is equal to b. If we write x is equal to a and y is equal to b, then it is equal to fab plus h fx ab plus k fy ab plus 1 h square by factorial 2, yes, fxx ab hk fxy ab plus k square by factorial 2 fyy ab. You can deduce from there. Just write down a is in place of x and b in place of y. From the earlier deduction, you can get this equation. Then some other corollary, because which form will be coming in the examination, we don't know. We have to get aware of the other forms. Now we put a plus h is equal to x, so that h is equal to x minus a, and b plus k is equal to y, so that k is equal to y minus b. Then fxy will be equal to fab plus x minus a fxab plus y minus b fyab plus x minus a whole square by factorial to fxxab plus x minus a fxyab plus y minus b whole square by factorial to fyab. This is another form of dual series. Whichever is convenient, you can remember. There are actually three forms of Taylor series expansion. The convenient one you should use. And remember, you have to remember, because in the problem you will not be given, formula will not be given. So you have to remember these three forms. Actually, we shall use this form. That is, I have indicated it is as equation number 1. This is the another form of Taylor series. Some other corollary. If you put a is equal to b is equal to 0, we get this much. fxy is equal to f00 plus fx00 plus yf00. This is actually famous Maclaurin series for two variables. Sometime they will be asking for what is Maclaurin series. Just in Taylor series, you put a is equal to 0 and b is equal to 0. You get Maclaurin series, right? If you put a is equal to 0 and b is equal to 0, in the Taylor series, you will get Maclaurin series. I think you have heard this, what is Maclaurin series. Now, this is the theoretical part which is required. There are other theories also there. I am not discussing because your syllabus, I have to cover your syllabus. Expand e to the power x cos y in the neighborhood of L pi by 4. Okay. From equation 1, say equation 1. Equation 1 is this. Put there, equation 1 is this. fab plus x minus a fxab partial derivative plus y minus b fyab partial derivative. So this, if you substitute like this, then you will get fy is equal to f1 pi by 4, because the basic point AB will be taken as the point which is given in the problem, L pi by 4. Is it clear to you? Because in the problem, the neighborhood of the point will be given. So that you have to utilize. So instead of AB, we shall write f1 pi by 4 plus x minus 1 fx 1 pi by 4 plus y minus 4 pi by 4 fy 1 by pi by 4 plus x minus 1 whole square by factorial to fx's 1 pi by 4. Is it clear? It's very much. We have just utilized the equation number 1 and then substitute a is equal to 1, b is equal to pi by 4. Now you have to search out everything. 1 pi by f1 pi by 4. What is that? Let us find out one by one. F xy is equal to e to the power x cos y. So f1 pi by 4, it will be, if you put x1 in place of x and pi by 4 in place of y, we will get e by root 2. And is it okay with you? I think, is it okay? You want to find f1 pi by 4. So fxy is equal to e to the power x cos y. So you put x is equal to 1 and y is equal to pi by 4, you get e by root. Clear to you? All right to you? Paritra?
Yes, sir.
Okay. Then partial derivative of, Okay, okay. Just
So
a
some people are
substitution.
waiting.
Yes, yes.
So some people are waiting to join.
Oh, acha, somebody is there. Saket. Oh, more are there. Okay, let me admit it because they'll be missing in that class. Coming 3-4 minutes late. So, yeah. Oh, somebody also there. 80. Orphan still. Shantanu Noskar. Sagar. Meghna Chakraborty. Oh, already somebody were waiting for me. 2-5 minutes is by it will be there. There should not be late. Now is already there. So now I shall start once again. Not from the beginning. The beginning they are missing. Who are late comers will be missing. What can I do? Now, yes, partial derivative of f with respect to x. It is e to the power x cos y because derivative of e to the power x is e to the power x and cos y. So now you find fx 1 pi by 4. So put x is equal to 1 and y is equal to pi by 4. You will get e by root 2. Okay. Next one, fy is equal to partial derivative of f with respect to y. So it will be minus e to the power x sin y. No problem about it. So it's fy 1 pi by 4 is minus e by root 2. Right. Similarly, we find out fxx 1 pi by 4, fxy 1 pi by 4, fyy 1 pi. This much is needed. The higher derivatives were neglected. So we substitute in the earlier equation this one is 1. Just you substitute these values 1 by 1. So we will get this form. E to the power x cos y is by Taylor series expansion. We get it e by root 2 plus x minus 1, e by root 2 plus y minus pi by 4 minus e by root 2 plus this one. So this is the final result. Wherever you take a Taylor series expansion in the vicinity of the point 1 pi by 4, the last is the result, confirmed result. Taking common and all these things, here they arranged it. So the last is, if a problem of Taylor series is given, first you check up what is the neighborhood of the point, and you remember the formula. So from this formula you find f AB, then you find fx AB, then you find fy AB, then fxx AB, etc. 1 minute note, phone is coming. হ্যালো, হ্যাঁ বলছি যে এখন ক্লাসে আছি, আসলে জিজ্ঞেস করছিলাম আপনি একটা কি নোট পাঠিয়েছেন না সেই না আর কিছু জানাই না আমাকে, আপনারা ওই নোটটা পেলাম। আমি তো আপনার 12টা থেকে 12:15 থেকে অ্যাকচুয়ালি অন করে দিয়েছি। এখন চলবে, এখন 1টা অবধি চলবে। মানে এদেরকে কিছু বলতে হবে এটা? হ্যাঁ হ্যাঁ, টিসিএস এর। হ্যাঁ হ্যাঁ সেটা। হ্যাঁ, ওরা অনেকে অনেকে কি করেনি আর কি। ও ও আচ্ছা, এই গুগল ফর্মটা যেন ফিল আপ করে, এটাই বললেই আমার হয়ে যাবে। ও আচ্ছা, গুগল ফর্মটা ফিল আপ করে যাতে অবশ্যই পাঠিয়ে দাও। ঠিক আছে, ঠিক আছে, বলে দেবো, বলে দিচ্ছি। ঠিক আছে। Yeah, the another problem, because there's some interaction in phone. So find the first 6 terms of the expansion of the function e to the power x log 1 plus y in a Taylor series in the neighborhood of the point 0, 0. So what is the neighborhood of the point 0, 0? So the function is fxy is e to the power x log 1 plus y. So one by one we find out fxy is e to the power x log 1 plus y. So f 0, 0. What is the neighborhood of the point? Point is 0, 0. They have given it the problem. So I shall use 0, 0. F 0, 0 is equal to 0, and then fx is equal to e to the power x log 1 plus y. So fx 0, 0 is equal to 0, and fy is equal to e to the power x by 1 plus y. So you know that the differentiation is, you are well aware of. So e to the power x by 1 plus y. So fy 0, 0 is 1. So this way you find out the each terms and substitute in the Taylor's expansion. Fxy is f 0, 0 plus x fx 0, 0. They have considered the third derivative in this problem. So in the earlier problem, we actually didn't use the first derivative. Second derivative was last. So here the third derivative is also given. So okay, you can take care of. So substitute the previous values here. So Taylor series expansion of the function in the neighborhood of the point 0, 0 is y plus 1 by factorial 2, 2xy minus y square plus 1 by factorial 3, 3x square y minus 3y square plus 2y square plus dot dot is equal to this. So the job is over for this problem. Anybody has any question? Meghna, you are clear with you? Because this will be the normal speed. So if I slow it down, then the syllabus will be a very danger point. So you just tell me that you are just going well with the problem. Meghna, Arthro, please just tell me about your doubts or anything.
No, sir.
Okay. So I am happy that you have no doubt. So it is straightforward substitution in Taylor's expansion. You have to remember only Taylor's expansion. That's all. And next problem, problem number 3. So evaluate approximately log of it. It will be actually cube root. Yeah, they have written it as square root. It will be cube root. They are mistaken printing. Cube root of 1.03 plus fourth root of 0.98 minus 1. So fxy is equal to, take the logarithm of this one, log of x to the power 1/3 plus y to the power 1/4 minus 1. Because first of all, we take it is as x and next one as y. Then I shall replace it afterwards, no problem. Because that will be easier for me to substitute in the Taylor's expansion. So f x plus y plus y plus k is equal to x plus h whole third plus y plus k 1/4 minus 1. Now f x plus h y plus k is equal to fxy plus h del f del x plus k del f del y, but omitting the higher powers. For convenience, they have neglected the higher powers. You can do it. In some problems, you can take second derivative, third derivative, depending on the problem. If you put second derivative, you may come with you, but no problem. But for simplicity, they have only taken up to second one. So this is the expansion. Log x to the power 1/3 plus y to the power 1/4 minus 1 plus h. This is the first derivative of x to the power 1/3. So del f del x is 1/3 e to the power minus 2/3 divided by, because logarithm is there, so it will be x to the power 1/3 plus y to the power 1/4. You know, because of logarithm, it will come down. Then you differentiate the internal, then 1/3 x to the power minus 2/3. Similarly, k del f del y. So this is logarithm is there. So 1 by 1 x to the power 1/3 plus y to the power 1/4 minus 1, and the earlier one is 1/4 y to the power minus 3/4. Putting, now we take back. We have put x and y, but it will be actually x y is equal to 1. So hk will be 0.03 and minus y. See, you can understand that log 1 plus 0.03 and 0.98 means 1 minus 0.03. That is why they have taken hk as 0.03 and minus 0.02. Is it clear? Somebody may be there, too late. It will be too late because I am admitting, but too late for you. Following you problem. So first you substitute xy as 1.03 and y. Then after calculation, it will come as this. Add substitution x, y, 1 and hk is the fluctuation from x. H and k is 0.03 and minus 0.02. So it will be log 1 plus minus, substituting here. This is 1. This is 0.03 into 1/3 minus 0.02 into 1/4. The result is 0.005. Next one. Expand x square y plus 3y minus 2. This is a function in the powers of x minus 1. That is in the vicinity of 1 minus 2. They have tackled quite suitably. Actually, neighborhood of the point minus 1 and 2. Sorry, 1 and minus 2. Because x minus 1 and y plus 2 means x is equal to 1, y is equal to minus 2. And substituting, they have taken the up to third derivative. So all the terms will come like this. All the terms of degree 3, higher degree, then 3 vanish. So yeah, I just assume it because third order is more than sufficient. So you put a is equal to 1 and b is equal to minus 2, not y is equal to. It's a mistake. I pointed out they are printing mistake. It should be b is equal to minus 2, and then the result will be, now we have found out the corresponding points, and the result will be this minus 10 minus 4 into x minus 1 plus 4ay plus 2 minus this. So, any question? Should be, oh, I should go at that point. Before that. Today I shall teach you only the application of Taylor's theorem. Where is that? Oh, The next earlier problem, yeah. Sorry, it calm down. Yes. So this is the expansion of x square y plus 3y minus 2. Oh, there is something to tell you that many of you have not just filled up the Google form. The HOD has just rang me that please to let you know that you should fill up the Google form today itself. Huh? Please.
Sir, किसर Google form?
Google form of Pro that actually I'll just tell you that which
I
form
guess CS
yes
না I guess সিয়ারদের একটা ওইটা মেবি I don't know মানে সিয়ারদের ভোটিং এর জন্য সেকশন 8 তে একটা হয়েছে গুগল ফর্ম তো ওটা হয়তো
আচ্ছা আমি বলে দিচ্ছি which form oh this is TCS TCS Code Vita Google form that is essential for second and to fourth year student to improve the placement and internship prospect. So the HOD has told me that to let you know that you have to fill up this form for your greater prospect of job. So according to TCS, the statistics and number of co-vita is a major measure of all institutes. So total number of second year, third year, fourth year is 1410 in your college, but out of which 947 registered for COVID. So there are left only about 400. So they should fill up the Google form. That's what I've noticed. Right? Please ask and fill up the Google form. Must be in your mail. I don't know. That is some notice I am just telling you because I have instructed to tell you that for your better prospect, you have to fill up the Google form and the COVID test and appear in the test. So that will just encourage and higher prospect will be there for placement. So about 400 something, they have not filled up the form. That's what the information came to me. Actually, I am not handling the placement. Okay, so please take care. Arijit Chakravarti, so late. 91. Oh. Acha, okay. I'm coming to the point. Already 50% has been discussed. So expand x plus y plus k divided by x plus h plus y in powers of h and k up to the second degree terms. So f x plus h y plus k is equal to x plus h y plus k divided by this. This is fxy. And fxy is, of course, if this is fx plus h y plus k, then fxy is xy divided by x plus y. So first derivative is this. I will not tell you how to do the first derivative. It is already you are well or derivative is nothing for you. So first derivative with respect to y is this. Second derivative with respect to fxx, that is second derivative with respect to x is this. And fyy is this. And fxy is this. So substituting in the Taylor's equation, you will get the final result. Xy by x plus y square by y plus y whole square h plus x square by x plus y whole square k minus y square by y plus y x plus y cube h square etc. So I don't think it is a problem. You have to catch the point that if x plus h y plus k is this, then fxy must be xy by x plus y. That is the catching point. So if you catch this, the problem will only substitute. Right. Another problem. obtain the expansion of tan inverse y by x about 1, 1. This C. Again, the point is given 1, 1 up to third degree terms. So fx is equal to tan inverse y by x. So f11 is equal to tan inverse 1. That is pi by 4. Del f del x is equal to 1 by 1 plus y square by x square into minus y by x square, and turns this is minus y by x square plus y. After arrangement, fx at the point del f del x at the point 1 1 is only minus half. We will substitute x is equal to 1 and y is equal to 1. This is half minus half. This much is clear. Very easy problem. Del f del y is this x by x square plus y. So del f del y at 1 1 is half. Fx is equal to minus y x square plus y square to the power minus half. So f xx is this. So fxx 1 1 is half. So fy, similarly you are finding fy, and fxy is 1 1 is 0, fyy 1 1 is minus half. So fxx f triple x, that is third derivative with respect to x. One side derivative, second derivative, and then third derivative is this. And so fxx 1 1 is equal to minus 1. And xy, xxy, so fxy is this. So again, differentiating with respect partially with respect to x, you will get this. It's very clear because u by v method, y square minus x square is u, and x square plus y square whole square is v. So u by v method, you will get xxy, and so fxxy 1 1 is minus half. After getting all these quantities, similarly, a lot of calculation. You have to get ready with the calculation and substitute in the Taylor's theorem in the vicinity of the point 1 1. So this result is this for long one, pi by 4 minus x minus 1 into half plus y minus into half plus 1 by factorial 2 x minus 1 whole square by 2 minus y minus 1 whole square by 2 plus 1/3 of this. So you know there is no facility of writing down and reducing so far. So you just come up with your exercise book and just you will see that you will getting the result. No problem about it. Now find the expansion of cos x cos y in powers of xy up to fourth order terms. So fxy is very simple. If cos x cos y they told, so fxy is cos x cos y. So f00 is 1. If you put x is equal to 0 and y is equal to 0, it's 1. Because cos 0 is 1, again cos 0 is 1. First derivative is minus sin x cos y. So fx 00 is 0. Similarly, all these quantities will be found out. Proceeding thus, it is easy to see that this one, all this are 0 and 1, just you check up, no problem about it, and get the final result as 1 plus half x square minus 1 plus y square minus 1 plus 1 by 24 x to the power 4 plus 6 x square y square plus y to the power 4, and these things. And there are some problems for your homework. Expand the following series in Taylor's form. I send it and send the literature, no problem. So you have to take care of. And next item will be maximum and minimum. So I think today will be too much for you because you have to go with this say a curve like G kind of coming up and coming down. So, and continuing, coming up and coming down, coming up and coming down. So it has one maximum point. How many maximum point? See, if a small part of the curve is given to you, you'll get one maximum point and one minimum point. Next day I'll discuss the maximum minimum point. So if the curve is suppose sine wave, it is going up and going down, going up and going down, going up and going down. So there are number of maximum, number of minimum. Okay, so we have to find out what are the maximum points and what are the minimum points from the, this is in your syllabus. It will be with diagram in the next class because today only 5-10 minutes left. So I cannot finish and it will be too much for you. So if a sine wave is there, there are maximum, there are number of maximum and number of minimum. So maximum of the maximum is called global maximum. I'll discuss. And minimum of the minimum is called global minimum. Right? And this is for a line. Suppose there is a surface. In surface there is a top point. Suppose a surface like that, a net, like going up, coming down and going up. A net. Or for catching fish, there is a net. This net is wavy, suppose. Surface is wavy, that is going up and going down and again going up and going, because in the sea, it cannot retain on the flat. There are waves in the sea. So going up and going down. So what will happen? What will happen? That the surface also have maximum minimum point. That we have to find out is in our syllabus. In a surface, what are the local minimum and what are the global minimum, and for that surface, what is the global maximum and what are the global minimum. So that will be discussed in detail with problems. So if you are able to do one or two problems, because it is sanguine question, what I guess, maximum minima will be Taylor's theorem also, and maximum minima will be a sanguine question. It will be discussed in the next class with diagram. Otherwise, you cannot catch so easily. So if you can do one or two problems, then it is nothing to you, because the mathematical calculation is there. You are not going to the net. You are not going to the net to catch fish. It is a mathematical calculation. Anytime it can be found out with the following calculations that we'll discuss in the next class. Because I think only 5 minutes left. So just any question about today's class, you can tell me, right? The boys. So go through the today's note I send you. So this is our discussion. Nobody is asking any question, any problem. So please see the Google form for Pro TCS, because this is an issue to be followed. And if you fill up the form and come in the examination, then this will just initiate your courage how to deal with this. So thank you today. Next class will be on Tuesday. That will be maximum and minimum will be discussed. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.